And to shamelessly steal from one of my favorite comedians, welcome, welcome, welcome. We are back after a summer break that seems like an eternity, but was only 3 months to get some much needed rest and recuperation and enjoy what little sun the Dutch summer managed to give us this year. But we are back with some awesome speakers tonight so that we can carry on helping you with your serverless journey. Leanne, hi. It's fantastic to see you again.
Thanks. It's great to be back. Yeah. Well, how was your summer besides wet?
Yeah, wet. There were some nice days in there. I've spent a lot of time in the dunes this summer. I've had a lot of downtime. Not really blogging, not really doing much except for Lego and walking in the dunes. It's been really nice.
Cool.
Yourself?
I was hiking. I visited my family in Germany I was gone for a month. I was doing all the traveling that I didn't get to do the last 19 months in like 5 weeks, and it was amazing. Weather could have been a tiny bit better, I guess, but we chose to live here. Yeah, exactly.
It's been fine. I've been doing also a mixture of online and actually real life talks. I've actually stood in front of people again.
Fantastic.
And it's been phenomenal to actually see people again. So
yeah. How was it? Like, describe it in one word.
Awesome. That's the best way. Also, it was stressful, it was enjoyable, it was just, the whole thing was just awesome. I did live coding for my very first one for Azure Thursdays, and just looking over the top of the monitor into the audience every now and then, it was just kind of, there's actual people here. I'm not just looking into a ring light and camera like I am now.
Yeah, I can totally relate. I also went to my first in-person conference. We were in the same city, just 1 week apart, apparently. But like, what I loved most was after the conference, hanging out with the other like speakers and just having like a beer together and getting into really weird, super deep conversations just because you spend so much time together. I really missed that. That was my favorite part of every conference, and I'm so glad I had that.
Something I've learned in the last 2.5 years since I've been a speaker, the speaker community is just amazing. There's so many great people out there, and you go to a strange city with people you don't know, and it doesn't matter. You still meet fantastic people. You have great conversations. You've got the camaraderie.
Absolutely.
Online talks have been nice, and I'm still doing some online talks because it means that I can talk without actually taking a week off of work.
Yes, that's a good argument.
It doesn't actually beat going there and seeing people and talking to people after your talk as well.
Yeah, for sure.
Yeah.
Cool. Do we want to move on to the slides and the housekeeping?
So let's get started. So welcome everybody to Serverless Days Amsterdam. Now, we are still online, as you can obviously see. We're discussing what we can do to actually get back into some physical in meetups, how to do hybrid events. We will be communicating more about that over the coming week or month or so. But at least this way we can get back, we can start talking to you again and line up some great people from around Europe. Little reminder for everybody, first Wednesday of the month. We've had 3 months off, but from now on, first Wednesday of the month is Serverless Amsterdam's Days, and we will be bringing the talks to you. And then we just have a little bit of housekeeping to do. First of all, we have our Discord channel. So if you want to chat to us, if you've got questions for the speakers, then please go visit our Discord channel. You can put your questions there. You can chat with other people there. We'll pass your questions on to the speakers at the end of the talk. And of course, our code of conduct. We want to be a welcoming, friendly place to everybody. Please take a look at the code of conduct. Make sure that you agree to it by being on the stream, by being in our Discord chat. You are agreeing to those rules. So please make sure you know what you're agreeing to, and let's make the world a nicer place. Finally, we are always looking for new speakers. So if you want to come and speak for us, if you want to help us organize, then please get in contact with us. If you really want to give speaking a try, but it's this big, scary thing that you can't imagine yourself doing, contact us as well. We would love to help you get started in your speaking world, in your speaking life. We'll help you, see what slide you can organize and try and give you a bit of mentoring to get your first talk out there and make it amazing. So now that we've got our housekeeping out of the way, I would like to introduce our first guest. Let's bring him into the stream. And that is Twan Koot. Hi, Twan.
Hi, how are you doing?
Well, I'm not doing too bad, thanks. It's been nice. Now, a bit of an introduction here. Twan is a lead performance engineer at Ordina. His focus is on improving the performance of applications, of complex systems. And he is an active coach and gives talks on a regular basis about the performance engineering field. I first met Twan earlier on this year. We've just been re-architecturing our application. And we thought we'd done everything right, but we really wanted to make sure. So Twan came in, he tested it for us. He found some stuff that we needed to fix. So, on the one hand, awesome. He definitely earned his money. On the other hand, we missed stuff. And he's going to come and talk to us today about scaling to the stars and beyond.
Yeah. So it's good to be having a new talk already. It's good. Still online. I prefer the in-person talks, but it's still good to have an opportunity to share some love about performance engineering.
Absolutely. I think the online meetups, the online conferences have been amazing over the last 1.5 years or so. Yeah. It's been, without that, life would have been very different for the last 18 months, I think.
Yeah.
Okay, if you'd like to share your screen, Twan, then we'll let you get started.
So I won't have any vision on the stream. So if you can say if it's sharing, then it would be really great. So.
Okay, so we should have your screen. So we're going to drop out and Twan, take it away. Thank you.
Yeah. So really wonderful to be able to talk at the ServerlessDays Amsterdam. It's the first non-performance or testing event I'm talking. So that's something new. It's always good. I did this talk like last week, which was in person, which was really great. Only had 15 minutes, so you guys are being treated with the whole talk about for more than 35-40 minutes. Hopefully, aiming for that. About auto-scaling from a performance engineer's perspective, it's a mouthful, but let's first start with the introduction. Stacey already gave some, but I'm Twan Koot. I'm a lead performance engineer at Ordina, 28 years old, and I'm based in Almere, which is, some people say it's Amsterdam. I won't agree with that, but it's fitting for the theme for this event. I always do this introduction with a couple of pictures with my favorite technologies and my hobbies mixed in between. I'm fortunate enough to really enjoy my job. It's also sort of my hobby. I love to tinker around with technologies, clouds, and performance testing, even in my spare time. So I currently use a lot of K6 and Microsoft Azure for performance testing. I'm a certified trainer in Neoload. And in my spare time, I really love to ride my Honda. So I do around, especially during the lockdown, I did around 10,000 fun kilometers. So not commuting to work in the Netherlands when the sun was shining. I don't mind the temperature as long as it doesn't rain. And I'm a fan of Formula One. So there's a quick reference here and there to cars and Formula One within the slides. Stacey already mentioned I'm working at Ordina, and you can reach out to me with this email address or send an invite or a connection invite over at LinkedIn. So let's start with a bit of terminology about autoscaling. when I'm talking about auto-scaling, I do split up the word in two. In scaling, which for me is increasing the size or count of servers computing power used to host or serve your application, web shop, database, data warehouse, microservice architecture, you name it, everything can be scaled. And auto is the automatic process of scaling. So it's as simple as that. Unfortunately, it isn't that simple. The topic isn't new. It's maybe as old as I am. I'm from '93, so I believe they do also have plans about I did read an article which dates from the '90s about auto scaling or scaling in general. But it really took a flight when AWS and Microsoft Azure Kubernetes came into play and start offering really easy ways to scale your applications, and of course automatic scaling, so auto scaling in general. As far as I'm seeing, as of this year, I see especially on Azure that auto scaling is really scaling up. Nice joke. In terms of popularity or being used by clients we have at Ordina. Scaling can be done up and down. So during the talk, I will definitely be mixing up scaling down and scaling in and out. But scaling out means going up in amount of servers or size, and scaling in means going back down to a minimum state of your infrastructure. So now we have these terminology introductions out of the way, we can dive into the first type of scaling or auto scaling, which is one of the most powerful and underused, if you ask me, is scheduled auto scaling. It's as simple as that, is having a fixed time or dates on which the infrastructure scales. For instance, during the night, well, I hope that you all go to sleep and don't start coding or visiting websites. So during nighttime, the traffic on your website or application should be next to zero. So why do you have these machines, VMs, containers up and running when you don't need to? So having a fixed time to scale down your infrastructure is what, for me, it's called scheduled auto scaling, and it's really powerful, and everybody can think about the times when there aren't any users on the system, and it's a good moment to scale down for most applications which are being used in the office. During the weekends, they are unused. And it's also the other way around. But you look at something like Black Friday, when most websites or web shops have a super increase in traffic for their online sales. And that's a good moment to schedule some extra machines or databases or front-end servers to handle the traffic spike. And you can easily do that by scheduling auto scaling in Microsoft Azure. It's as simple as 2 clicks and you have scheduled auto scaling up and running. The other 2 types of scaling are vertical scaling as well as horizontal scaling. Vertical scaling is the change in size. So increasing from 16 gigs to 32 gigs of memory, or scaling from 2 vCPUs to 8. That's increasing in size, and horizontal scaling is scaling in the amount of nodes, containers, VMs you have available to serve traffic. So these 2 types of scaling are the main shows of the main stars of the show. So when we have some examples about vertical scaling, it's not really rocket science, to stay in terminology of the slides, but increasing the VM size, as already said, going from 16 to 32 gigs of memory is a type of vertical scaling. Changing your Azure App Service Plan, again, going from a P1 to a P2 is vertical scaling. And also decreasing, for instance, your Docker container CPU limit. That's also a term of vertical scaling. Looking at horizontal scaling, increasing the amount of VMs is horizontal scaling. Setting up an AWS autoscale group or setting up Kubernetes HPA, which is all types of horizontal scaling. I've talked about what is autoscaling, some examples about horizontal and vertical scaling. But why do you want to autoscale? As a performance engineer, I would love to say it's all about performance and giving your end users and all your users on your system the maximum amount of performance during any circumstances. Only, I need to be honest, it's a lot to do about money. For the most part, autoscaling it's easier to save money with it than have the ability to handle load spikes. So next to thinking about autoscaling to ensure performance is also a really good method or technology to decrease the amount of unused infrastructure. During my first years as a performance tester or engineer, I worked at the government, and they had a huge data farm, hundreds of servers, which was being used on average for 10% during the whole year. But there were a couple of moments each month on which it was really busy, and that's why there were so many servers or CPUs or VMs necessary. When you start using autoscaling, you can decrease these unused infrastructure, thereby have a huge cost reductions, and then also benefit if you can handle load spikes way better. So when the load does increase or you have more traffic on your system, you would be able to have better performance. I have an example of this from Facebook. It's maybe a bit strange having an example of Facebook in recent events, but this has nothing to do with the router updates they had. In August of 2014, it's already 7 years ago, they start using autoscaling to bring down their energy costs. You can imagine that a huge data center full of servers takes up a lot of energy, which is really expensive, especially at this time. So they had a blog post about this, and they reported a 27% decline in energy use on the low traffic hours, so midnight, in the weekends. That's not applicable for Facebook, but during the off hours of traffic, and a 10 to 50% decline in energy use over a typical 24-hour cycle, which is pretty huge. If you look at the costs it takes to running the energy costs it takes to be running a data center, 10 to 15%, it's a huge amount. It's maybe millions of dollars. And the same applies for big companies like Netflix. They would love to decrease their unused infrastructure because they also have thousands of containers or VMs running around. So I talked about the benefits and why you want to do autoscaling, but scaling also has an impact. Because when you do scale your infrastructure or your configuration, it changes things in the system, and this will change your behavior of the application. It can be a positive effect. It can also be a negative effect, because increasing the amount of nodes or VM or size may introduce new bottlenecks between your database and your backend servers. Increasing the amount of servers may actually decrease performance. I've seen it happen that we had a performance issue. We start increasing the VM size, and it only kept getting worse. I sort of compare it with I find it one of the most beautiful episodes of Mythbusters. They had I can swear a little bit, maybe a shitbox of a car, and they strapped a couple of rockets to it and send it off into space, sort of speaking, which sounds like a good idea. How can you make this car faster? Well, let's strap some rockets to it and light them up, and it just flew away. But if you know Mythbusters, it didn't end that well. So it starts flying and exploding all around. And the same happens when you apply auto-scaling to a system which isn't properly tested or properly coded. So throwing more speed or more processing power at an application which has bad code doesn't fix anything. Having a wrong architecture or having a wrong design doesn't magically poofs away when adding auto-scaling into the mix. So the same goes for not performance testing your application at all. It's a really bad idea. I once had I did a performance test at a client, and we had really bad performance. Let's say it took like 16 seconds to log in, and it took over a minute to get your personal information. And so I did the performance testing. I said, well, guys, we need to fix this because this isn't acceptable. And the manager just said to me, well, just buy more Intel to fix the high response times. Well, you could imagine that buying more Intel wasn't the solution. The solution was redesigning the whole application and having a proper architecture to support high loads. So please take into account that having auto-scaling doesn't mean you have better performance or you have an application which doesn't crashes during high loads. So we need to test auto-scaling. That's what I want to say. And how do we scale? How do we test auto-scaling? We can determine a couple of test scenarios. The first three are we can test the minimum size, which is the amount of infrastructure or containers we need, let's say during the night when there's really low traffic on the application. That's the minimum size. The desired size is the scenario where you have your typical day-to-day load on the system without any spikes or just a normal day. And the maximum size is the infrastructure you need for those Black Friday super high intense traffic moments, which there are a couple of each year, of one a month. So these three scenarios lead to the following load plan for performance testing. So we start off at the minimum size and we apply the load with something like K6 or NeoLoad, and then we can see, well, the performance is good, so we add even more load to the system, and we're going to the desired size and eventually to the maximum size. And you can do this load test fairly easily. That's no big deal, but it's missing two key components of auto-scaling. So this scenario is only 1/3 of the testing which needs to be done. I always say, and here's the sneaky Formula One link I already promised you guys, what goes up must come down. Auto-scaling also means scaling down. So it's not about scaling up. I think it's really important to focus more on when you can scale down and how you can scale down properly. So identifying the desired performance levels for scaling down, because there's a lot of focus when implementing auto-scaling on scaling up more and more machines, more processing power. And I think the focus should be on less. How can we do the same performance with the least amount of infrastructure, and when needed, scaling up? So that's the first part which was missing in this load plan. And the second part is scaling in and out means a new baseline. And between the maximum and the minimum size, there are a lot of stages. So you also need to test the scaling in and out of the system. And how do you determine when you need to scale? Now, well, you can do that based on a couple of metrics. And the metrics can be split up into three main types of metrics. We first have hardware-based metrics, which are CPU usage, processor queue, memory usage, disk I/O, you name it. We all know these metrics, which is pretty common to have in your monitoring systems. Secondly is performance metrics. So we can also scale based on performance metrics. I can determine the average response times, let's say the percentile of 95 or 99, to determine if the performance is decreasing. So we need to increase maybe the containers to bring the performance back down. And the last category of metrics is user-based metrics. Well, this can be active users, it can be errors, functional errors on the system, but also something completely off topic, a marketing campaign. When the marketing team has come up with a real brilliant marketing campaign, which is being launched next Friday, it's probably a good idea to have some extra service at the ready to handle the increased load which this marketing campaign can trigger. So scheduled auto scaling would be a really great solution for a marketing campaign which is being launched next Friday. There isn't any go-to plan on selecting these metrics for auto scaling. It really depends on the type of application you're using, what kinds of architecture you use. Is it serverless, or is it do you using Java, Python? In general, it's a mix between metrics. So using hardware and performance, as well as user metrics, to determine your auto scaling is sort of the best way. When we take this all in account, we get a new testing scenario. So when I do testing for auto scaling, I always follow this plan, which starts at the minimum size, which definitely takes into account scaling out to the desired size, going up to the maximum size, and also scaling down. Because I think the most important thing about the testing are the yellow parts within this presentation. So scaling out and back in, because those are the tricky moments on which the system determines, well, I need to add more power to the system because traffic is going up or response is degrading. But scaling doesn't happen instantly. So in that moment, it takes a couple of minutes for the system to spin up a new container or a new VM. So this is the most critical part for any scaling solution or testing for that matter. So it's really key that you have a load setup or a load plan for auto scaling, which includes scaling out and scaling in. So when analyzing auto scaling, you need to have a couple of things. You need to have a focus on a couple of things. First of all, you need to compare the scaling in and out moments with the moments you would expect the system to be scaling, because you wouldn't be the first DevOps team which said, well, we want to have auto scaling when the response times start degrading at let's say 2 seconds, and then during testing you come to the conclusion that it starts scaling at 5 seconds. Secondly, you need to compare the performance levels of each phase. So, and each phase, I mean the minimum size, the desired size, and the maximum size, and if that lines up with your expectations of performance. And during scaling in and out, look for anomalies like dropped sessions because new users are being routed to the new node in the system. Maybe increased error rates because the system isn't scaling up fast enough, and even spikes in response times, because it can happen that when a new instances of Azure App Service Plan is being put in the mix, the first users which are being led to that new node are experiencing higher response times. It's a bit counterintuitive. Scaling up leads to higher response times, but during the initial scale up moment, it can happen. So it's something to be looking out for when analyzing these auto scaling moments. And it may be something when I say this, it's something you say, well, that's logical that we don't forget this, but really keep in mind that when you do have auto scaling, don't forget your application gateway, because if there's an increase in load, auto scaling your backend service, it's good, but maybe your application gateway is screaming for more resources, especially the Azure one. It's really prone to auto scaling issues I've experienced. So don't forget other components in the system. Any linked systems or third-party calls. Let's say you have a microservice architecture and your team started implementing auto scaling, and everything is going really fine. It's really busy on the server, so you add an extra node, and you get a call from a neighboring DevOps team saying, "What the hell are you guys doing? We are experiencing high load." So what I want to say is that always check if you have any links to other applications, or maybe a good Google Analytics or Google Maps integrations, that by increasing your performance, you may be decreasing the performance of those third-party calls, which in the end leads to even worse performance. So keep that in mind when auto scaling. Always make sure you aren't blowing up any of your neighbors, because they don't like that. I've experienced it many times. And of course, don't forget your databases, connection pooling, because auto scaling seem to be more and more focused about backend servers than databases or configurations like pooling. Again, something which is, this is really tricky to get right, but there's a fine line between vertical and horizontal scaling, in terms of it may be better for your system to have a really big machine and scaling way later than having a small machine and scaling in smaller steps and scaling more often. And this is also really depending on how fast does it take, how fast does the system, how fast does the scaling happen? Because scaling isn't snapping your fingers and there's a new machine which is ready to serve requests or handle traffic. It can take up to 5 minutes for a system to be able to handle traffic at the desired performance levels. So keep that in mind, that during scaling or during selecting vertical or horizontal scaling, that it may be better to switch over to a bigger machine and scaling less frequently, or saying, well, I want to have smaller sized machines and scaling more on a horizontal fashion to have a more detailed level of grip on my performance. So that's again really dependent on what type of architecture you have, and you need to experience this. So start testing your auto scaling and see, maybe experiment a little bit with having a really big machine and scaling way later than you were before, or do the other way around and start using smaller machines but increasing the amount of auto scaling you would be using, then increasing the amount of auto scaling you would normally use. Again, watch out for these. It's 4 issues, but I can name more and more. But when dealing with auto scaling, prevent the yo-yoing effect. And what's yo-yoing effect means is going up and down, up and down, up and down during the day. Again, auto scaling isn't a magic button which in a nanosecond adds extra machines or extra performance to your system. So scaling up and down only brings extra complexity into the mix. So prevent the yo-yoing of your infrastructure. Also, time your scaling. I already mentioned in the previous slide, but it's really important to determine if if scaling happens in 1 minute or in 5 minutes, because if it takes 5 minutes for machines to be up and running and handling traffic, you might want to be scaling up sooner. And if it really is a flick of a button and there's a new machine which is able to handle traffic, you maybe are prone to scale up a little bit later than the other way around. It's really handy to set up a maximum amount of infrastructure. So having a maximum amount of nodes or VMs which you can use for scaling. And the reason is that maybe some bored ITer is DDoSing your website, or I'm performance testing your application. And if you don't have a maximum amount of service defined, the system will generally keeps on adding more and more machines into the mix, which is a costly endeavor. So always set a maximum amount of service you want to use, or maybe say, well, for us, it's okay that the performance is on average 5 seconds during something like Black Friday, because adding more machines into the mix only increases the cost, but doesn't lead to any better performance. So that's also something you maybe can take in account. The same goes for having a minimum size. You wouldn't be the first DevOps team which doesn't set up at the minimum desired infrastructure. So during night times, your let's say Azure thinks, well, it's really quiet on the system. Let's scale down everything to barely to zero or barely any machines. So then the next morning, the first couple of minutes or the first users which are logging in onto the system may experience really bad performance because there isn't any resources left. So then it takes a couple of minutes or maybe hours to sped up the system by scaling up again. So always set a minimum and a maximum size for your infrastructure. And I use this term overscaling. I don't know if it's the proper term, but I find it quite fitting for this behavior. It's always use a cooldown period to prevent overscaling. And what I mean by that is when scaling happens, be it scaling in or scaling out, don't do anything for a couple of minutes, maybe 5 to 10 minutes, maybe even 15 minutes, because it takes a little bit of time for the performance or infrastructure to reach the desired effect of the scaling. And if you don't have a cooldown period after a scaling action, what could happen is that the system says, well, it's really busy on the platform right now. On the platform right now, I should add 5 extra front-end servers, and so it starts scaling. And 5 minutes later, it checks again. Well, it's really busy on the platform. Let's add 5 more machines. And then 5 minutes later, it says, well, oh, it's still busy. Let's add even more machines into the mix. So by implementing a cooldown period, you prevent this type of overscaling of a system. So that's really important to use. And I've seen in effect that not having a cooldown period would lead to having 99 servers, 99 backend servers in your infrastructure, which it's fun as a performance engineer to see, but it isn't the right solution for the performance issues. So let's have a little recap of what I talked about. When implementing or testing or thinking about auto-scaling, you should take into account the 3 types of auto-scaling: horizontal, vertical, or scheduled. First, of course, as a performance engineer, always load test your application before starting with auto-scaling or scaling in general to have good design and efficient code. determine your minimal desired and maximum size, run load tests on these configurations, and you can use one load test or have separates to know, okay, this is the performance levels during these sizes. As a third step, determine key metrics. That can either be user, hardware, or performance metrics on which scaling can be triggered. You can set this up by using an auto-scale plan or set up the settings. Run the performance test for scaling in and out. So that's the load plan I showed you with the different sizes and the scaling in and out and going back down to the minimum size. And analyze the results and adjust the settings and rerun the test if needed. And you should be rerunning the test because setting up auto scaling, it's a tricky business, especially if you want to do it right and you want to have good performance during scaling up and scaling down. So you aren't able to set up auto scaling correctly by just doing one test. I think you need a couple of tests, maybe even 5, to be sure you have the right settings and there aren't any anomalies which can happen during scaling or doing any during the operations of the system. So this was my talk about auto scaling from a performance engineer's perspective. I hope you guys and girls really enjoyed listening to it, and I hope there really are questions, because I love to answer them and maybe clarify some things here and there. So I would like to ask for Stacy to join back in. Or
first of all, great job. Thank you for the talk. I didn't see any questions on Discord, but I'm going to check again. If not, so now is your time to ask questions on either Discord, or we're also checking the chat of YouTube and Twitch if you are not believe in Discord or whatever. In the meantime, I have a question actually. So in your experience, what's a very dangerous misconception maybe people have about auto scaling? I mean, you talked about the leave it alone for 5 minutes. I think that was a very important learning. But is there anything else you've seen people do?
So the main thing is that people think it's a sort of silver bullet for fixing performance issues. I think that's the general misconception. Because it doesn't fix any performance issues. For most performance issues aren't related to having too little CPU power or too little nodes in general. Most of the issues are related to code issues or bad designs.
Okay.
So
Do you think that using autoscaling will bring these issues out more? Will make them more visible, maybe?
If you have a really inefficient backend system, you have more servers on which you have inefficient backend service applications running. So it shows even more that you have an issue.
Right. Yeah, it makes a lot of sense.
It may appear that you have better performance because you added a little bit more hardware to it, but if you look at under the hood, it may be a mess.
Right. Yeah. That makes a lot of sense. So we have a question from Mark, our guy behind the scenes today, and he would like to know when is autoscaling good and when can it be bad? It's a very loaded question.
When it's good, I think when it's good is when you have the confidence in your setup that it can handle low traffic and high traffic. Then I think you have set up, you have good auto scaling. So as a DevOps team, you don't even, let's say that the marketing team came up with a last minute super mega sale. So there's going to be a lot of traffic, and when you as a DevOps team then know for, well, I don't care, the system will handle it, it will scale up, no issue, then it's good. If you start wondering about, oh shit, can we handle that amount of traffic, then you don't have the right auto-scaling.
Is there ever a use case where you think like don't use auto scaling here, or maybe a problem where you're like, this is clearly
if you really need snappy performance, don't use auto scaling, because it isn't the best solution for performance, to be honest. If you want the best performance, just set up the maximum amount of machines, nodes you need, and leave it there. Because scaling up an extra node may take up to upwards of 5 minutes. So that's something to take into account. If you want really the best performance, don't use auto scaling. Just set up the system the way you want and leave it there.
Yeah.
So that's why I really talked about. It's also it's a little bit about the money, unfortunately, but yeah.
I think you touched on a really good one there at the start, which I think it's something that people don't take into account enough. I'm really pleased you said that. And that is the whole, if your code's no good, this isn't going to help you. I have heard so many people, we want to move to the cloud because it's slow running it in our data center. And in the cloud, we can just keep on adding stuff to make it fast.
Well, no.
And Dan also says in Discord, over provisioning is a valid strategy for sure. Euro sign though, which I guess it means money.
Yeah.
So I feel that this is. Sorry, go ahead.
Yeah, we're really used to over provisioning. If you look at the old data centers, we tend to have the machine set up for that one moment of the year when it's really busy. So it's a bit of a mindset change for a lot of people to be going to the cloud and having the possibility into switching between sizes and amount of machines. That's something new. So we need to get used to it and start by learning the ropes.
Yeah, you don't have Black Friday every week.
No, so you don't need the machines every week.
Absolutely, but I guess it's a question of safety. I guess like for yourself to think like, okay, I've tested it now the week before, so now I can be 100% sure. But then you can never simulate that real situation anyway. Yeah. Okay. Do you, Tuan, do you have anything that you would like to add that didn't fit in your talk? It's super important to you for people to know.
No, start using the features, the wonderful features of the cloud, and start experiencing what it can bring. So have a playground machine on which you start using auto scaling, and hopefully the first time it goes wrong, so then you know, oh shit, I need to change something, and keep on learning. That's the main goal.
That's great advice. In any case, that's great advice. Thank you so much. So we're gonna go into a little break, right? We're gonna do like a 5-minute break next.
Yep, 5-minute break, and then we'll be back with Dan giving his talk on the state of serverless.
Fantastic.
So we will see you shortly.
Super excited about this. See you soon.
And we're back.
Hey, I hope you all had a good drink or pee break, because we are going to continue the meetup with Dan Marr, who is you might know him as one of the members of the Global DevOps Days team, or maybe as a technical evangelist for Datadog. And it's my pleasure to welcome Dan to the stage. Or I think Stace has to welcome him to the stage. Hey, Dan, how are you doing today?
Hey there. Yeah, I can't complain. This will be my third live virtual event today, heading into hour 6 of live content. So I'm a little bit loopy. If I lose the plot a little bit during the course of my talk, just reel me back in.
Right. Are you trying to set some kind of record or something?
Apparently.
How long can you go?
This is the online content version of luge, which is like the only Olympic sport you can do by accident. So
you have to tell us a little bit more about that maybe after your talk during the Q&A, because I am very intrigued now. Awesome. So you're going to talk to us about the state of serverless, right? For this year that's still ongoing.
Yes. Let's talk about that. That sounds great.
Well, I mean, we don't know what's going to happen the next 3 months. So I hope you're prepared. You're well prepared.
I guess we're going to find out. Do you have
find
a
out, yeah.
Yeah.
Would you like to share your screen right now, Dan?
Yeah, sure. Let me see. We'll click this button over here. We'll click this button over here. Apparently, screen sharing is best with 2 monitors. Well, it's good to know.
If you can afford it.
Yeah, exactly.
This is like a very privileged
there we go.
Here.
Ta-da.
Fantastic. Yes.
Nice. My second monitor, by the way, is a mobile phone.
Great.
That can work perfectly.
There
you go then.
As soon as you're ready, you can take it away.
Sure. Okay, that sounds good. So, hi everybody. My name is Daniel. I'm an engineer on the community team at Datadog. I am based where I am physically right now in this room where I have been for the past 18 months. This room is in Paris, and today I'm going to talk about sort of the state of serverless. Basically, in this year, 2021, what I'm going to be talking about is a bunch of data that we at Datadog have gathered on how serverless is being used by companies, large and small organizations around the world, within our customer set. And the data that we have gathered is data from 2020, because of course 2021 isn't over yet. Well, into the first part of 2021. And I'm going to present that to you here today. So very briefly, this is me. This is my email address. If you would like to get a hold of me, if you want to talk about some stuff later afterwards, feel free to take a screenshot of this. That's my Twitter handle as well. So again, feel free to get in touch. And I have been doing talks on presentations and workshops on a variety of computer-related topics, I guess DevOps and SRE and configuration management and stuff. For a number of years now. So if you like to check out some of the stuff I've done, go ahead with the portfolio there, be my guest. So as I mentioned, we're going to be talking today about data that we have gathered at Datadog. And we've compiled a small report, which we've made public for the first time this year. We haven't published our research on this in the past. We're publishing it now for the first time. That's the URL there. I will have a QR code you'll be able to take a snapshot of a little later, and we'll put the URL back on the screen again towards the end. But you can go and you can read the report. Now, what I'm not going to do here today is read the report to you, because that's not particularly interesting. If you want the report read to you, there's text-to-speech tools and things out there. Instead, what I'm going to do is introduce one of the items that's in the report, and then provide a little bit of illumination, provide a little bit of context, maybe a hot take, maybe a little bit of guesswork that we have around it, stuff that we didn't necessarily want to put into print, and send to the media, and then we can have a little fun, I guess, with the content. I have the Discord open, and if you have questions or you have comments, I'm going to keep a little eye on it as I go through this, and I'm happy to engage basically at any point in this presentation, which is one of kind of the fun things with doing stuff in virtual format, is that you can break the rules. No gods, no masters. Be the captain of your destiny, the architect of the adventure that is your own life, right? So let's do it. All right. Let's talk about Lambda. It's sort of the first thing that we want to talk about. Let's talk about Lambda. And to be clear, I'm going to be invoking AWS and AWS Lambda and other services around that quite a bit in this talk, which is not to say that there aren't other serverless facilities out there, providers out there and whatnot. We'll get to that in a moment. It's just that I can't talk about literally every single function as a service provider on the planet in the space of one talk. So for the purposes of this presentation, I'll be talking about Lambda a fair amount. So that's the little disclaimer there. So point number one is this, that Lambda functions are invoked more than they used to be, basically, right? So what we're seeing now, as opposed to in previous years, going back as early as 2009, when the very first sort of FAS services were starting to be proposed by some cloud providers, where it was very much an experimental thing. Today, teams are not just merely experimenting with serverless, right? They're making it a critical part of their software stacks. It's not the early adopter phase is over, basically, right? We're well into the established market space for serverless as a paradigm, if you will, right? Our research indicates that companies have been using Lambda, the companies that have been using Lambda since 2019 have significantly ramped up their usage. And in the case of Lambda, for example, they're invoked 3.5 times more often per day that at the start of 2021 than they were even 2 years prior, right? And additionally, within the same cohort of Lambda users, each organization's functions ran for a total of like 900 hours a day, which is a reasonable number, right? 900 hours a day worth of serverless that's running. That's on average, of course, aggregate over the cohort. Why is this important? Well, the upshot here is basically that the same developers and companies that were using serverless previously are using it more today. Why is that interesting? It's interesting because it is a signal. It gives us an indicator that serverless is not just a flash in the pan technology. It's not just the flavor of the month JavaScript framework. It's not some sort of wackadoodle AWS service that some VP somewhere had to spin up in order to get a promotion, and it's gonna fade into obscurity a month from now, right? Serverless is here, right? And it's being used, and it's being used more and more. And companies that are already using it are buying in every single day and using it also at increasing velocity. So it's becoming normalized. In fact, it already has been normalized, and the acceleration of the growth is increasing. And that's a good and interesting data point. If you are unsure, or if you're in a consulting position and your clients are unsure about serverless, this is an important data point to be aware of, right? So that's where I kind of wanted to start with this, right? Is can we establish, using some hard data, whether serverless is real, whether it's here to stay? And we think it is, and this is one of the data points that we're using to make that statement, right? So while AWS Lambda may have kickstarted the serverless movement, arguably, right? And a lot of arguments to be made there. But in a lot of ways, if AWS did it first, it's sort of a almost always true statement, even if it's almost never true. So Lambda was kind of the big one, and people are using Lambda, people are loving Lambda, but it's not the only game in town. It really, really isn't. And I mentioned this earlier. There's other providers out there. There's other options out there. Azure Functions, for example, and Google Cloud Functions have both seen growth in their own adoption within their respective cloud platforms, of course. In the past year, the share of Azure organizations running Azure Functions climbed from 20 to 36%. And on Google Cloud, nearly a quarter of organizations now use Cloud Functions, right? So we talk about organizations, we're talking about, organizations in the context of the cloud providers, not necessarily companies, right? Because a company could have multiple organizations. But we're seeing, again, increased usage across the board from the major providers. And this is also true on some of the smaller level providers too, that we don't necessarily quote in this report, just because our data is not as good. We don't have as much of it. But I don't want to say anecdotally, it's a bit stronger than that, but the trends look similar as well. Although Cloud Functions was the last of the 3 FaaS offerings to launch, right? Serverless is not a new concept in Google Cloud. The cloud platform introduced a Google App Engine, if you remember this, Google App Engine, which was the first fully serverless compute service back in 2008. 2008, right? So we think, oh yeah, like Lambda is this new thing and serverless is this new thing. As it turns out, no. It turns out that a major cloud provider has been offering serverless functionality since 2008. And before, if you were part of their beta program. So that's also an interesting data point. Today, we see the momentum, shifting towards, their newer serverless offerings, Cloud Functions and Cloud Run. But a lot of people actually still use Google App Engine. Those numbers are still non-trivial. Which again, when we talk about maturity, when we talk about whether a paradigm is a flash in the pan or something that's sticky, that is going to be driving the next generation of engineers, the next generation of organizations, that already happened with serverless. It's already a proven model, right? And that's an important data point. Now, this is only looking at sort of the functions as a service slice of the market, but serverless, it really represents a lot more, right? So Google started with App Engine and has Cloud Functions, has Cloud Run, as I mentioned. AWS started with Lambda, of course, but now it has several compute offerings that sort of blend containers and functions together, like Fargate and App Runner, and the ability to deploy Lambda functions as containers, which is like galaxy level stuff. Azure made it really popular to run services on top of pre-provisioned infrastructure. And Tuan earlier was talking about over provisioning and how do you deal with this stuff? And I'm going to touch on a little bit in this talk as well some of the problems around that. But so this idea of pre-provisioned infrastructure, dealing with cold starts and stuff. I think they call that app service plans, if I'm remembering correctly. There's many equivalent serverless products that you find on other clouds as well. So all of this to say that when we look at those numbers that you see here on the screen right now, those adoption numbers, we're pretty sure that we are under measuring these numbers because we are only taking into account the baseline FaaS, functions as a service services, so Lambda, Cloud Functions, etc., right? But when you take all these sort of blended options into play and all these sorts of, it's serverless, it's on sort of on the not, but it's sort of combined itself things together, we're not counting those things. So really we're undercounting these numbers, which again means adoption is here to stay. Now, to be clear, we're just talking about the adoption of serverless within cloud providers. I'm specifically not talking about roll your own type stuff, right? You got a Kubernetes cluster, you're running your own functions service on top of that, for example, OpenShift or whatever you've got going on. Absolutely, these are real things. Absolutely, people are doing it on-prem, hybrid situations, even rolling their own within the cloud context, spinning up EC2s and so on and so forth. That's not part of what we're talking about, but those exist too. So again, you see all these functions, adoption rates climb even higher. So while these numbers here are already impressive enough to make a bold statement like, yeah, okay, the paradigm is real, we're significantly under measuring them. And that's an important data point. Finally, this is not a race, right? But between them, who does it better? Oh, AWS is winning, or blah, blah, Google's been around longer, right? That's not what I'm talking about. Serverless takes a lot of different shapes, a lot of different forms. I'm not making any sort of a value judgment here, and I want to be clear about that, right? So if you're running it one way and someone else is running it another way, as long as you're both happy with what you're doing, then you're doing it right. Right? All right. So let's look at point number 3. Let's talk about Lambda. I mentioned I'm going to talk about this a lot today. So Lambda is increasingly used to basically power to drive customer-facing applications that require low latency, right? That's just a fact. That's where we're seeing a lot of it now. So if your thing that you're providing is latency sensitive, there's a non-zero chance that you've already got it on top of Lambda right now if you're running in AWS, right? In 2020, the median Lambda invocation took just 60 milliseconds, which sounds pretty fast, right? 60 milliseconds, like that's That's pretty quick, 60 milliseconds. That's half of the previous year's value, which was 120 milliseconds, which is honestly still pretty fast, right? One possible explanation is that more organizations are following the Lambda best practices and designing functions to be like really highly specific to their workloads, which helps reduce the duration of the invocations. We also noted that the tail of that latency distribution is actually quite long, the long tail, right? We've heard of this term used before as the long tail, which suggests that Lambda is not just powering short-lived jobs, but it's also more like computationally intensive use cases. And this is important, right? So there are two sort of elements here that I'd like to call out, right? One is that we're designing our functions to be more specific to our workloads, which means as an industry, we're literally getting better at serverless, right? There's not a stagnation in terms of innovation. There's not a stagnation in terms of understanding how to innovate within the context of Lambda. And this is true for the other cloud providers as well. The trends are very, very similar. And the second important element here is that whilst low latency, high speed invocations are prevalent and getting faster by the day, again, that tail is long, which means people are using Lambda to also run longer lived functions. And I think this is very interesting. And it was actually surprising to us. Maybe not surprising to you. I don't know what you're doing with your serverless functions, but it was surprising to us because it's not how we think about running serverless. When we think about running serverless at Datadog, we're like super, super tight, like we try to run it in 640K code, MS-DOS, right? Fast as possible, but that's not the case for everyone. It's really, really not. And we think it's a sign that developers are experimenting and doing fun and interesting things in this space. And that's another sign of the maturity, another sign of that level of adoption, right? It's worth noting, and I get into this a little bit later, but spoiler alert, the environment and the language you use really, really matters here, right? So if you're running like Python or Node.js functions, you're probably on the faster side, the smaller side of that tail, right? Where you go, rapid fire little functions. And if you're running like .NET or Java functions, you're inching towards the longer side of that tail. And we can maybe talk a little bit why that is afterwards. But again, interesting data points here are things are getting faster, but not everything, right? Some things are getting longer. So let's talk about Lambda. Let's talk about step functions. So what's a step function? Step functions basically enable developers to build event-driven workflows, right? So steps, these event-driven workflows that involve multiple Lambda functions, and in fact, other AWS services as well. And we talk about blurring the lines a little bit between like, is it pure Lambda? Is it really serverless? And step functions sort of blur some of those lines, right? Now, within these workflows, step functions coordinate like the error handling, retries, timeouts, that application logic stuff, which helps reduce operational complexity, which is good, right? When you're scaling, when you're getting bigger, when you're getting larger, and do complicated things, being able to offload some of that application logic can be a real time saver, a real sanity saver as well, right? Now, again, happy to be talking about step functions here, but similar product offerings exist in the other providers as well. Our research indicates that the average step function workflow contains 4, count them, 4 Lambda functions. Is that a lot? I don't know. I said open question. And if you think it's a little, if you think it's a lot, if you think it's just right, I'd really be happy to hear from you, because we don't necessarily have a good baseline for how the industry is thinking about this. All we have is a baseline for knowing that the average step functions workload contains 4 Lambda functions, which seems to indicate that that's where as an industry we've settled. But is that where we're going to stay? We don't know. The important thing here is that this number is slowly growing on average, right? So we haven't yet released our data for 2021 because, somewhat shockingly, 2021 has not yet ended. However, I can tell you, don't tell anyone else that I said this, but I can tell you that this number is getting bigger month over month. So it's creeping towards 5, creeping towards 6. Why is that happening? We don't know. A sign of maturity, a sign of adoption. Really want to talk to you about it. If you're using step functions, I'd love to get your feedback on this. And I mean that sincerely, right? So what's going on there, right? So step functions are being used for both. I hesitate to use the word real time, although it certainly gets thrown around. Let's say low latency, right? Highly rapid workloads. But also, as you can see here, when you look at this distribution curve, it also tails off. And we're seeing long running workloads here as well. This isn't as shocking to me, at least, as it is just frankly interesting, right? So one of the ways we're thinking about this is we look at step functions and we go, they support things like express workflows, which are designed for synchronous real-time use cases, where a user is blocked when waiting on a response to a request. And this makes it relatively straightforward to run complex multi-step tasks with conditional logic, for example, within a web app, right? And that could be a reason why these are lasting longer and longer, because we have this idea of step functions that are waiting on user input, that are waiting on branching, conditional logic to get through different steps, that could be waiting on different types of input. And again, we're talking about step functions, so we could also be waiting on input from other AWS services and stuff like this. It's a little difficult to tease out exactly why, but these are some of our guesses. We also have an inkling that people are using step functions in particular to deal with extremely large processing jobs. So you look at the very far end of this graph, and again, I think it's interesting, is that there are functions running for like more than 24 hours. We, not uncommonly, see step functions running for a week, and we have seen more than one step function running for like a year, which I don't know what's going on there exactly. If you are using really long step function workloads, if they're lasting days, weeks, months, let me know what you're doing with them, because I'm super, super interested. The last time I presented on this here in Paris, actually just last week, someone said, actually, we have a long running use case. We basically implemented cron in step functions. So we're using it as a task scheduler. So it never dies, like ever. It's designed to run forever. And I was like, wow, that's actually really neat, right? Like there's a cool use case. So that's one reason possibly why you might have step functions running for forever, is if you're writing your own queuing mechanism and basically replacing cron or implementing cron, in a serverless space, which is pretty neat. Again, really, really do want to hear from you. That's sincere. Let's talk about edge computing. I brought this up in the Discord chat already a little earlier because I think edge computing is really neat. I like to talk about it. So let's talk about edge computing. There's a lot of buzz around edge computing for its promise of like faster data processing, be close to your user, et cetera, right? So today we can assert that about a quarter of the organizations that use Amazon CloudFront, again, I'm talking about Amazon, it's broadly similar and other providers, but a quarter of the organizations that use Amazon CloudFront are taking advantage of Lambda at Edge. Lambda, it's a service, Lambda at Edge, to deliver content to a targeted or even global user base, right? You have the classic example, like what do you do with edge computing? What do you do with that? Oh, I don't know. You could like dynamically transform an image based on device type, right? Are they on a mobile? Are they on a desktop? Like whatever, right? And that's the classic example. And I'm sure a lot of people do that. But one thing that we've seen a lot of our customers doing, which I think is a lot of fun, is doing A/B testing, right? But at the edge. Which is really, really cool. So like delivering subtly different versions of apps or different, feature flagging and whatnot, but doing it at the edge, which is a lot of fun. There's a lot of different use cases for it. Now, again, to be clear, the statistic is about CloudFront, but we do see more and more customers adopting other edge compute providers. Cloudflare Workers comes to mind, Vercel, Netlify, super popular. So moving your functions to the edge isn't necessarily super common, just like using functions, but frankly, it's not uncommon either. And the rates of adoption there are climbing as well. But I would say that the chances that your use case would be served better by edge functions than just functions in general is not as common. So maybe that's why it's not as common. Wow, tautology for the win. Okay, let's move on. The other important thing about edge functions in general, and again, we're talking about Lambda, but this is true kind of across the board, is how short-lived they are, right? In other words, they run really fast. So, and you're going to see that little blip at the end. You're thinking, what, Dan? What that? You're showing me a graph. You said that's really fast. What's that stuff at the end? We'll get to that. We'll get to that in a moment. In general, we talk about that long tail, of serverless functions. Everything runs in 60 milliseconds and a little bit longer towards the end. In general, edge functions run really fast, or they don't run at all, right? Edge functions are designed to be fast. Our data show that a little over 2/3 of edge functions run in under 20 milliseconds, which is substantially and materially different than the statistics for just straight up Lambda, right? There's a big difference between 20 and 60 milliseconds. As anybody who's ever tried to optimize bytecode will tell you it's absolutely the case, right? So this suggests that edge computing has really enormous potential to support super latency critical applications, and to do so with frankly minimal overhead, which is I think is one of the neat things about it, right? But it's not necessarily the easiest thing to implement. So with a Lambda, you can just be like, I have code, and now it's in a Lambda, and now it's running, right? And that paradigm is not difficult to get your head around once you start to get the idea of doing like IOs and queuing and stuff like this. Doing stuff at the edge is different enough that you do have to start thinking about re-architecting. In some cases, you have to worry about caching issues, and you have to worry about DNS stuff maybe you didn't need to think before. And there's other issues that start to come into play that make it just difficult enough that it's not for everybody. I'm not trying to scare you away from it at all, okay? But again, I'm just giving you permission to not be an expert in it already and to be like, hey, you know what, we want to check this out. It doesn't make sense to us right away. We think it's still difficult. All those things are true. It is a little bit difficult. It doesn't make a little bit of sense at first, and that's okay. We do expect to see edge computing as a technological paradigm, as an architectural paradigm, to mature in the same way that other serverless paradigms themselves have matured and have been maturing for a decade or more at this point. And again, while we are concentrating in our report and in this slide here on AWS, we did observe similar trends in other edge function environments. But what about that blip at the end? What about it? So we see this nice, beautiful curve that goes from 0 to 20, and then 20 to 40, and 40 to 60, and then it just sort of trails off. And then at 180 milliseconds, there's a spike, right? So unlike long-running Lambda invocations, which could be doing data processing jobs and all sorts of cool things, unlike long-running step function workloads, which can be doing a variety of interesting and in some cases wackadoodle things, this one here we're pretty sure is mistakes. We're pretty sure this is people not using edge functions properly, because we can't think of another reason why the curve would look like this. That said, if you are running edge functions that routinely take 180 milliseconds or more to run, and you're doing it on purpose, I legitimately want to hear from you. This is not a shame thing. I am super curious about what you're doing with that. Please get in touch. I really do want to know. Okay. Let's talk about something that was brought up by Tuan in the previous talk. We're going to talk about cold starts. We're going to talk about provisioning, right? So when a function is invoked after a period of inactivity, and of course here we're going to talk about Lambda, but the general case is also true. there can sometimes be a bit of a delay in that initial execution. This is cold start, right? We've all experienced cold starts before. Shouldn't come as a surprise to anyone. Now, for applications where latency is an issue, where you don't want to take that hit, right? Cold starts can be a problem. If that first touch is important, then you need to find a way to deal with it. This is not the case across the board, right? Talk to your product owner to see if cold start is right for you, right? But what we could say is that at the end of 2019, when AWS introduced provision concurrency, big P, big C, it's a thing, to help Lambda users sort of combat this cold start, we saw some things change, not necessarily for the better. So the idea is with provision concurrency that you can keep your execution environments basically on the ready. They're initialized, they're ready to respond to request. There's no startup time. And this is the same. We see this in Azure, we see this in Google, we see this in other cloud providers. They have a similar thing, right? But that provision concurrency, it comes with its own set of concerns. Again, touched on this. I shouldn't even say this. Went into great depth on this in the previous talk. So I won't spend too much time here. But I do want to say that based on our data, how to put this politely, we're screwing it up as an industry. Is what it comes down to. We're doing a bad job with figuring out how to do provision concurrency. That's just a fact, right? Provisioning that and configuring rather the optimal amount of provision concurrency for Lambda functions, and this is true, of course, across the board, remains a challenge for basically everybody. So we've seen that like over half of functions use less than 80% of their configured provision concurrency. So less than 80%, which means there's an over provisioning issue there, right? And meanwhile, over 40% of functions use their entire allocation, which is an under provisioning issue, which means that they're still going to encounter cold starts, even though they're paying for provision concurrency, which, yeah, right? Either way, both use cases are incorrect from an optimization and most importantly, a cost perspective, right? And it's not like, oh, some little bit of problems over here, it's a little bit of problem there. No, it's like over half of all provision concurrency is doing it wrong, right? And that's real money, and that's real impact on user experience, and potentially a real impact on your business and how your business functions, right? So if you're thinking to yourself, what can I do within my organization to be innovating, to be driving value, right? To be, that person that can really make a difference within the context of the stack deployments, in the context of serverless deployments and whatnot. This is a place to start looking, honestly. And if you're thinking about what your next startup idea is, this might also be a place to start looking, right? Because this is a real problem, and it's a real problem for everyone. Large companies, small companies, doesn't matter the cloud provider, doesn't matter what you're doing or who you are, there's a better than half chance that you're not doing it correctly. It's an unsophisticated application of this paradigm of pre-provisioning or over-provisioning or under-provisioning. We're not doing it well. The last thing I'll mention here, and this is the quiet part out loud, is that the language again matters. I mentioned this earlier, that for short-lived lambdas, probably it's Python and Node, and long-lived lambdas, probably it's like Net and Java. Here it's actually the same thing. Within that group of incorrectly provisioned infrastructure, right? If you're using Python or Node, you are way less susceptible. If you're using Net or Java, you're way more susceptible. Part of that is because with the latter languages, there's just more stuff that needs to happen, right? We got to like load our structs and we got to import a bunch of stuff and blah, 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 right? So you're going to feel the pain of that startup time more acutely. Again, no value judgments here, right? It's just a statement based on the data that we have observed. All right. Let's talk about this. Point number 7. Out of curiosity, there's 8 points. We're on point number 7 now. Let's talk about scale. As serverless applications scale, deployments basically become an issue, right? And this statement is true. I could remove the serverless from that. As scale increases, deployments become harder, right? So whereas you might be able to get away with manually deploying X, Y, or Z, if you're only having to deploy like one EC2 instance or like one Lambda function, you just do it through the console, pointy clicky, and do it yourself. That's fine. But once you're talking about like fleets of machines, or once you're talking about like dozens or hundreds or thousands of functions, you need some way to manage that deployment, to deal with the configuration management of that, the lifecycle management of that, right? And doing it manually it gets cumbersome and error prone real fast, right? So there's a couple different ways to deal with this. CloudFormation, right? If you're in AWS, CloudFormation is kind of a big one, right? So the idea there is that you've CloudFormation, you can provision AWS infrastructure, and other types of resource stuff into collections, right, or stacks if you want to be more generic about it. And it's the underlying deployment mechanism for higher level frameworks, especially in the serverless world, like the Cloud Development Kit, the CDK, the Serverless Application Model, the SAM, right? And of course, the serverless framework, the elephant in the room, serverless framework. It's CloudFormation underneath. So among these tools, serverless framework, which is open source, pretty cool, is by far and away the most popular. Now, again, if you're not using serverless framework, this is not a value judgment. I'm not saying, oh, you got to change it or you're doing it wrong or whatever. I'm really, really not. This is just a statement of fact that serverless framework is by far and away, when we talk about Lambda, we talk about CloudFormation, it's the one, right? It's used by over 90% of organizations that manage serverless resources within the context of CloudFormation. That's important. But of course, there are 19% other options, right? 19% use vanilla CloudFormation, which is a trip. CDK, 18%, 13% using SAM. That number is dropping, by the way, over time. You'll note, if you're following along at home and paying attention, that these numbers don't add up to 100, right? You go, how can you have more than 100%, Daniel? I don't think you're allowed to do that. Well, in fact, organizations may use multiple deployment tools, multiple deployment models, right? It's not like if you use serverless framework, you only use it, or if you use SAM, you only use it. And that's why these values add up to more than 100%, because you can double up or triple up or quadruple up on this stuff fairly straightforward, right? I don't recommend that you do, but people do it. Why did they do it? Different teams have different ideas about how they want to run stuff. That's fine. Legacy stuff where you move from one model to another, right? That's fine. Could be a ton of reasons why, right? Again, whatever works for you. This is what people are doing though, serverless framework. If you're spinning up a new serverless stack today, I would recommend using that one until the next good thing, whatever it is. So let's talk a little bit more about that. Among the CloudFormation stacks used in serverless applications, like 65%, bordering on 2/3, contain only one Lambda function, right? One Lambda function. So we're taking and we're using this big deployment model, and we're learning a whole new paradigm, and we're buying into a whole new AWS way of thinking, and we got to manage this on our back end, and we're doing all of this 2/3 of the time to literally deploy one function. Furthermore, over half of all functions, around 57%, are not deployed with CloudFormation at all. So remember this earlier slide here where I said everybody's using serverless framework? That's only if you're already using CloudFormation. Turns out over half of all functions being deployed aren't even using CloudFormation at all, right? So this suggests to us that a lot of organizations are still sort of in the early stages of automating and optimizing their serverless workflows within the context of sort of infrastructure as code, right? So infrastructure as code is not new. Infrastructure as code has been around for a very, very long time. CF Engine, right? Puppet, Chef, et cetera, et cetera. A lot of organizations are not using infrastructure as code paradigms to manage their serverless life cycles. Not yet, at least, right? There are a surprising number of companies that are managing their Lambda functions with basically bespoke deployment tools, stuff they've rolled on their own at home, CI/CD pipelines right from a Git repo, all sorts of really interesting and fun stuff. And again, no shame. If this is what you're doing and it's working for you, keep doing it, right? Don't rock that boat if you're happy with it. And this is why, one of the reasons we think at least, why we see so many CloudFormation stacks with kind of only one function, is that as an industry, as technologists, our level of maturity there is increasing. We have an opportunity, right, to sort of level ourselves up in this area. It's worth noting we weren't able to measure Terraform usage consistently enough to include it in this report. We use a lot of Terraform at Datadog. We deploy everything at Datadog, and we deploy a lot of things with Terraform. As far as serverless is concerned, and especially with Lambda is concerned, it's not a good fit right now. And that, for example, is an opportunity for Terraform as an open source project to sort of move things forward. And I'm not trying to call out, our friends at Hashi or anybody working on the Terraform project. I'm just saying that when an infrastructure as code tool and platform as mature and well established and well loved as Terraform is at a low level of maturity with regards to Lambda functions, then there's no way that we can expect really anyone else in the industry to be at that level either, right? This is just a thing we need to work on. And again, if you're thinking to yourself, what's my next startup idea? You can have that one for free too. Okay. Last point I want to get to. Point number 8. Since 2018, Lambda has offered support for 6 runtimes: Node, Python, Java, Go, .NET Core, and my personal favorite, Ruby. As an aside, I really like Ruby because it basically just allows me to write Perl. I really like Ruby. Anyway, I digress. Worth noting that Python and Node basically run the show when it comes to Lambda usage, right? They account for like 90% of all the functions, hands down. 90% of all functions, either Python or Node, right? 58% of all deployed Lambdas run Python. That's up 11 points from a year ago, with another 31% running Node.js. Important to note, that's an 8-point dip since last year. Again, we're not making any bold statements about why that is. It's just a statement of fact based on the data, right? Among functions written in Python, over 90% use Python 3, which is good and true because Python 2 went end of life quite some time ago. Python 3.8 is the most popular version, which is also a good thing. And Python 2.7, which is still used, but it's actually down 25 percentage points from a year ago as users basically increasingly migrate to Python 3. If you're still running Python 2.7 in your functions, I would suggest you basically stop doing it. It's a bad idea. If you're running Python 2.7 anywhere in your production code base, I further suggest you stop doing it because it's a bad idea. But again, I am making a bit of a value judgment here, and I'll stand behind that one. What was I talking about? Right. So if you're using Python and Node and you're doing it in Lambda, you're in good company. When we examine the breakdown of runtime usage by environment size, and now the wording here is very, very specific. I'll get to why in a second. The breakdown of runtime usage by environment size. There's an interesting trend. Node.js edges out Python in small AWS environments, right? So if you've got a small AWS footprint, Node.js more likely to be used within the context of Lambda in specific. Python becomes increasingly popular as the size of the environment grows. Not the size of the number of functions, not how long they live, the actual AWS footprint. So among organizations with the largest AWS footprints, Python is used 4 times more often than Node.js. Now, again here, the wording is important. We're not talking about the size of companies. We're not saying that, only multinational organizations that employ hundreds of thousands of people, they're the ones who use Python and startups use Node. No. We're talking about AWS footprint here, which is correlated to sigma, I'm not sure, with the size of organizations. But again, footprint size shares a strong correlation with whether you're using Python or Node. As of March 2021, so a couple of months ago, because we're still compiling data, but as of March 2021, the top runtimes by version are in order: Python 3, Node.js 12, Node.js 10, Python 2.7, stop using it, Java 8, Go 1, .NET 2.1, and .NET 3.1, in that order. If you are using anything other than Python and Node, it's not that you're doing it wrong. It's not that you shouldn't do it, right? It's just that you're doing something that not a lot of other people are, and that's okay, right? Blaze your own path. Right? Be the champion that you want to see in the world, right? Anyway, that's it for me. Here is, again, the URL to the report. You can go and take a look at it, but I feel like I covered all the best stuff and then gave you more anyway. But if you do want to check it out, pass it around to your friends and family, hand it out at work. This is a QR code. Feel free to click, snap, whatever you need to do. Take a look at that. I'll leave that up here on the screen for another brief moment. And I am happy to, take some questions, be interactive, and, thanks for checking it out.
Thank you so much for that great talk. Now, I
Thank you.
first saw this talk a few weeks ago in Zurich at the DevOps Days conference there, my first in-person conference in a long, long time. Am I right in remembering that you basically translated it from French the night before that you gave that talk to fill in for a speaker?
I translated it from French on the fly. Yeah.
And it was an amazing talk. I am really pleased that you could come here and give that talk again for us today. Second time through, it was just as even better than the original. So thank you.
Well, that's very flattering. I appreciate that. The first time I was stumbling a little bit because I was, like I say, I was translating into English as we went. But I took, I took the speaker notes and I put them in, and so I could deliver it more fluidly this time through.
It was really cool. We don't have any questions in Discord, but as a .NET developer,
sure,
I've got a question for you. That the whole duration of functions when it comes to using .NET or Java, it takes a longer time. Mm-hmm. Is there any insight there? Is that because of the framework, or is that maybe developers coming from a place where you're more used to bigger, more complex applications and learning how to use these serverless resources in an efficient way?
I mean, the answer is yes. Right? I mean, it's all of those things in isolation, in various combinations, and then and more, right? We don't have visibility into actually what's running inside of the functions, right? We only have visibility onto statistics that are around them. So we can't say with any degree of certainty, I guess, exactly why that is. But we can make some guesses. We're developers, just like you're a developer, right? And so everything you mentioned, this idea of the frameworks themselves tend to be a bit heavier, right? I mean, that's just a fact.
Yeah.
That there may be some questions around maturity there, right? That people developers who are developing Node functions, developing Python functions, just as a cohort, have a greater level of maturity. That's possible, right? It's also worth noting that these numbers that we see in AWS are broadly similar on other cloud providers, including Azure, which is an important data point, right? You'd think, oh yeah, there's going to be all kind of .NET running on Azure, and in fact, you look at Azure functions, Node and Python are still super popular, the most popular, right? So, so we can sort of tease out from that, if we wanted to make some educated guesses, that among all of the .NET developers that there are in the whole world, and there's bazillions, that fewer of them are developing within the context of serverless, and that just statistically, as a result, there's going to be less maturity.
Yeah. I can appreciate that one. I mean, coming from my own career path, looking back over the last few years, I've worked for some rather large companies. I worked for companies that were reasonably conservative, and actually making the move to the cloud is already a big thing. And then making a move to this scary serverless world where we have way less control. Yeah, it takes a lot longer to kind of get that bulwark rolling. At least that's been my experience, I say, in several companies and speaking to several different people.
Yep. I mean, that's going to be true. I would say in general, but one of the things that I open with at the very beginning to sort of set that frame is that serverless isn't new and scary and weird anymore, right? And we have the data to back that up, which I think is important. So
Yeah.
if you're a consultant, if you're working for an SS2Z, like we'd say here in France, right? And you're working with state level actors, you're working with multinationals, you're working with organisms that correctly move more slowly, that act more conservatively because that is the correct way for them to act. Point them at this presentation, point them at at this report, because this is how to get that conversation started. Be like, no, like serverless it's not a toy, it's a real thing we could use today. Mm-hmm.
Absolutely. That was kind of the main question that I had out of there. Leanne, do you have anything?
Sorry, I was not finding the mute button again. Don't really have a question, but I would like to hear your opinion, Dan, because I was, mentioning when you were talking on Discord, and I was asking how many online shops actually need to go to the edge, and you were like arguing that you're basically 90% there already. So I'm just from kind of the opposite side. I'm guessing, like, as a consultant, I used to just tell clients to please stick to your core business and don't go and, manage your own Kubernetes cluster if you don't have to, if this is not part of your core business. So where would you draw the line, or is there a line for you? Are you just looking at technical capabilities?
Right. So yeah, I mean, don't go chasing waterfalls. Right. Please stick to the rivers. Okay. I miss karaoke.
Always good to take. Oh my God! Don't
Are
even
you kidding me right now? God, I miss karaoke.
But yeah, go ahead, please.
Serverless Amsterdam Meetup 2022 live karaoke. We're doing it.
All right, you heard it here first.
Heard it here first. So, I'm being a bit tongue in cheek, on the Discord, but when I say we're, if you're watching the stream, not on the Discord, literally what I said was like edge functions aren't for everybody, right? But there's a possibility again that you're already almost all the way there and you just don't know it, and that's kind of the perspective I was looking at. Like if you're already running, a FAS platform of some type, right? Especially on a major cloud provider, to be clear. And you're already optimizing for latency and you're already optimizing for resource utilization, which generally means, isolated functions and, and dealing with, retries and things like this in tight loops before failing. You're already talking about resource overhead, right? And you're already managing that, again, within the vendor ecosystem context, and that vendor ecosystem provides edge as a feature, then you're already, again, you're like 90% of the way there. What I'm not saying is that less 10% is a big 10%, right? And that's why I say it's not for everybody. It's a maturity thing there on both sides of the coin. It's a maturity in terms of us as technologists understanding how to exploit edge computing as part of our own models. It's not something that we as an industry have, like everyone knows how to, we can type, we know how to like plug things together, we know how to write a for loop. These are just things we know how to do, right? We're not there yet with edge computing as an industry. And as I said, it's both sides of the coin, is that the edge compute providers, their services are not at the same level of maturity as they are with some of the other things that they provide. So when you're thinking like, okay, I think edge is interesting and I think this is something that we can benefit from, you're also making a commitment to doing a thing not everybody is doing, to doing a thing that you can't just necessarily Stack Overflow, to doing a thing that your peer group might not be able to help you with as much, right? And you're also further committing to that ecosystem. You're further committing to that vendor, which is something, you know, that maybe not everybody wants to do. So like I said, that last 10% is a big 10%.
Nice. That does sound like serverless was at 5, well, like maybe more 2 years ago, when it was really more like no one was really doing it. Now we're seeing it from our like talk contributions, and you just see more talks about real life use cases. So yeah, let's see where edge computing goes. I think it's super exciting as well. Maybe we should do edge days sometime.
Don't Google that.
Edge Days Amsterdam.
Don't Google that.
Oh, okay. All right. I'm scared now.
But yeah, so I think it's the next thing. Honestly, edge computing, I think, is sort of the next thing that we're going to see in the serverless world. I mean, unless something gets invented, some really cool thing can get invented, next quarter or whatever. That's entirely possible. But that's the next thing, right? Is bringing those functions as close as possible to the consumer. And again, consumer, right? Whatever that means within your context, right? Whatever or whoever or so forth is actually executing those invocations. One of the ways that I've seen this done effectively is for hyper-localized like data distribution, right? Where say you've got a fairly large data set of some type of costing data or some type of, well, I have to stay generic about this because I can't talk about it publicly. You have a large data set of cost data, but that data is hyper-localized, right? Regionally. It could be at a region level, a country level, a sub-country level, a city level even, right? And being able to query that data and get a response on that data at high speed is literally the most important thing. The smallest data set that you can deliver is going to give you the fastest response by default, right? If you've got 100,000 rows, finding the thing you want in 100,000 rows is longer than finding the thing you want in 10 rows, right? But how do you know which 10 rows to deliver? That's where edge compute can be interesting, right? Because your vendor's already got the network. All you have to do is split out your data, right?
Nice. Yeah. It's super exciting. I agree with you that there's lots to discover. So let's see what's happening in the next 3 months. So you might have to update your talk.
Almost certainly.
Great. Stace, back to you.
Yeah. Well, thank you very much for your talk there, Dan. And well, hopefully we'll have you back again at some point because it was a magnificent talk. And like I say, we've got to update this for next year anyway.
It's true.
And yeah, tot ziens for now, as we say in Dutch.
Okay.
Well, what do they say in wherever you are right now?
Well, I don't know what you just said, so I can't translate that.
Oh.
I guess it'd be au revoir.
Ah, there you go. Au revoir.
Yeah, it's true. All right.
Bonsoir.
So, au revoir, Dan.
See you.
Bye-bye.
Bye.
So that was our first talk. I don't know what you thought, Leanne, but I enjoyed both of those talks. I got an awful lot out of it, and it's just so cool to be back.
Yeah, definitely. I was definitely very well entertained. I learned a lot as usual. Apparently, we have an Afrikaans viewer also. I'm seeing that right because tot ziens is the same in Afrikaans. Lots of similar words between Dutch and Afrikaans. But yeah, I was super happy to be back. I know we're going to try and keep up the monthly cadence, but we're also going to look into hybrid options. So that's also what I'm very, very happy with.
Yeah, it's going to be so nice to be able to see people again. And it's the interaction. We do the best that we can with the interaction online, but it's always different in person.
Yeah, definitely.
It's always different when you can actually see the person you're talking to directly in front of you.
Yeah, for sure.
Okay, and I think on the last note, before we disappear, the slides up again. Like I say, we are always looking for speakers. If you want to help us, please get in contact. If you want to give speaking a try, get in contact, and we will happily help you get started. And I guess on that note, I'm going to go and have something to eat now because it's getting
late.
rather late for me.
Yeah, for sure. Have a good night.
Have a good
See you
evening,
soon.
everybody. Thank you for joining us. Bye-bye.
Bye.